When you define a source in ASAP, you can obviously propagate the light through the optical system and perform any number of forms of analysis, but you can also analyze the source before you propagate the rays to verify, for instance, the source distribution or apodization or the extent of the source or any of the other source properties. I'm going to open up a file where I've simply created an ASAP source and then applied an apodization function to it to create basically a Lambertian type distribution. Then what we're going to do is just look at the source. We're not going to trace rays from the source. We're just going to look at the energy, if you will, as it sits on the source before doing anything. That was pretty quick, so let's take a look at the data. The first thing is the intensity at the source in a direction cosine space, and then we can look at it in an angular space as well. And what we see is a relatively Lambertian type of distribution, which is what we would expect because that's the apodization space we defined. The other thing we can do is take a look at what do the rays look like, where are they? And I'm going to come under Rays and select Graphics. And what we can do is just look at the position of the rays in a three-dimensional space. So we just have a flat surface where rays are being emitted from that surface with a Lambertian energy distribution. So let's take another look at the rays, but this time let's view them with arrows associated with them to get an idea of which direction those rays are heading. In ASAP, when you define a source that has rays, the rays contain much information, not only where they're located in an X, Y, and Z space, but also the direction cosine that ray will have as it propagates, and also, if you desire, information about the polarization state and other ray energy information as well. So let me just click on OK. And what we see now is, in a more three-dimensional sense, little arrows indicating where the rays are headed as they leave the source. And within ASAP, you can define virtually any type of source by using these apodization factors. You can define virtually any mathematical function and then apply that to a source, and ASAP will create an energy distribution based on that function. And you can analyze it and verify that the output of the source is indeed representative of the source you're trying to model.